The TW9 theme is food.
Ooh. Students were charged to develop new products.
There were 8 teams, each with 16 to 20 students.
Each team was given a budget of $6,500.
And they all had 3 months.
If you do the math, that works out to be 100 billion person hours.
Of fun!
Each presentation should last approximately 8 minutes. Please hold your questions
For the 5-minute Q&A to follow. Are you ready?
It's my pleasure to introduce Red Team.
We designed our product, the Gaia Milk Dryer, to be a device that would allow farmers to convert their fresh milk into powdered milk. Picture yourself as one of the 5,000 dairy farmers in Guyana, a small tropical country in South America. You have around 8 cows and scrape together a living by selling the milk to your local community. You milk your cows twice a day, but you can't sell the second batch because it spoils overnight. You see that over 75% of milk consumed in Guyana is imported, powdered milk, but you can't offer a domestic alternative because you have no way of producing it. In addition, you'd like to sell your milk to the cities where demand is highest, but you can't because gallons of milk are just too hard to transport. There are so many ways you'd like to expand your market, increase your income, improve your livelihood, but you can't because the technology just isn't there. And you're not alone. This problem is repeated in country after country across the developing world. To solve this problem, we created the Gaia Milk Dryer, a low-cost, manually powered device that would allow farmers to convert their excess milk into powdered milk, which could then be transported easily and stored without refrigeration. Before we go into the details of how the device works, we'd like to show you how it's used. The user starts by lighting the furnace, using wood or whatever other fuels are locally available. Once the fire is lit and the drum is sufficiently hot, the user pours the milk into the reservoir. When the reservoir is full, the user places a container to collect the powdered milk and takes a seat in front of the pedals. The user then initiates the flow of milk via a valve near the seat and begins pedaling at a comfortable rate. The Gaia Milk Dryer would now begin producing powdered milk at an intended rate of 2 gallons an hour. When, during the process, the fire needs additional fuel or to be stoked, the primary user can call over a second user working nearby to help tend to the fire. In this way, the primary user can dry milk continuously without having to leave the pedals. When all the milk is dried, the user collects the finished product, turns off the valve, and walks away. In between each use, we recommend putting a little bit of water in the reservoir and running it through the device so as to steam clean the drum while the fire dies down. Now let's dive into the technical aspects of this device. We modeled our process after industrial drum drying, so we had a basic template from which to progress. But transitioning an industrial process to developing world technologies at a much smaller scale presented some serious technical challenges. Primarily, we needed a way to efficiently capture a large quantity of heat and then transfer that heat to the milk near instantaneously, and finally, be able to regulate the whole process so that the drying surface stayed within a 5-degree window. To do all this without electronics, we turned to steam. Utilizing a high-efficiency furnace known as a rocket stove, the burning biomass heats the drum, which doubles as our drying surface. Apologize here. The temperature of the drying surface is regulated by a pressure release valve at the far end. Moving on to the applicator is essentially similar to a drip irrigation system, in that it consists of a perforated tube and a large reservoir. This provides a steady flow of milk onto the drum and is gravity fed so as to not require a pump. Moving on to the other side of the device, The scraper consists of a steel blade which rubs against the drum to peel off the powdered milk into the collection chute. At the center of the process is the rotating drum, which is powered by the user's pedaling and drives the process forward. Taken together, these components form an efficient yet modular design so that individual parts can be replaced and serviced as needed. Besides telling you how the device was designed, we'd like to show you how it behaves when it runs. Unfortunately, indoor fires are discouraged, so we'll run you a video instead. Here we have the furnace. Note the two intake slots, the one on the top for fuel, the one on the bottom for air. This improves the fire's efficiency dramatically. Now, moving on to the applicator, you can see that nice flow rate, as well as how the milk behaves when it contacts the surface of the drum. Then with the scraper here, ideally this would peel off the powdered milk and leave a good clean surface for the next round of application. As you can see, unfortunately this module still needs a little bit of work and is our primary area for further testing and development. Zooming out to view the whole process, you can see how each component functions and the user's role in powering the device. In terms of next steps, while we have produced powdered milk, our current prototype is not working at the level that we'd like. Specifically, the scraper, while we tried a number of iterations, is still not able to peel off that powdered milk and leave a good clean surface. In addition, we've recently run into issues with the Boston winter affecting our milk evaporation, so we'd like to do some testing in more tropical-like environments so as to eliminate these variables. Nonetheless, we are confident that our team can meet these challenges and aim to have a product by the end of January that we can begin beta testing with users in Guyana. I'll now hand you over to Tommy, who will go over the specifics of how these farmers will really benefit from this device.
When deciding where to market the Gaia Milk Dryer, we had a number of options available to us. With over 900 million dairy farmers worldwide, we decided to focus on the rural area, because it's here where any extra milk produced it spoils because they're unable to refrigerate it overnight. We had a number of contacts in different countries, including South America, India, and Africa. However, it was our contact in Guyana of South America that we were able to work the closest with. Thus, we decided to focus on marketing to the 5,000 rural dairy farmers there in Guyana. When pricing the Gaia Milk Dryer, we realized that we didn't have any competitors to benchmark against, because current milk dryers are built on an industrial scale and can cost anywhere between $8,000 to $5 million. So thus, we decided to talk with our contact in Guyana and ask him, how much do the Guyanese farmers currently spend on milking equipment, such as a cream separator, and how much would they be willing to spend on our product? We then decided on a price of $40 for the Gaia Milk Dryer. To give you a look into what the economy of an average Guyanese dairy farmer is like, an average farmer makes $3.27 a day on the milk that he's able to produce in the morning. If he was able to dry any of the milk that goes to waste at night, he can make an average of $4.10 a day. This 26% increase in revenue would allow the Gaia Milk Dryer to pay for itself in under 2 months. I'll look at our costs. The Gaia Milk Project is looking to be a nonprofit organization. This is because a Gaia Milk Dryer costs $200 to manufacture, and the most we can sell it for is $40. This $160 deficit can't be made up with economies of scale alone. So we're looking at non-governmental organizations to provide $45,000 a year for us to become a completely stable nonprofit organization in 6 years. Moving forward, our strategy is to contact these non-governmental organizations, or NGOs, specifically looking in agriculture or income generation. We're also looking more specifically at these large NGOs that can help us with the bigger problems of distributing, manufacturing, and translating into other rural areas. Some potential partners are listed below. Finally, as Brett had said, there's dairy farmers all over the world in these rural areas who are looking to expand their market, increase their income, and improve their livelihood. With the Gaia Milk Dryer, they can. The added $300 a year in revenue would allow them to provide food for their families, tuition for their kids, or help expand their homes. I'd like to say a quick thank you to all the people who have lent a big hand along the way, and thank you, audience, on behalf of Red Team.
Thank you, Team Red. My name is Professor Maria Yang, and I'll be moderating questions today. If you have a question for Red Team, please raise your hand, and Rich and Monica will come to you with a microphone so we can hear everything you have to say.
Hi.
Oh, sorry, Doug.
That's all right. Thanks. Quick question on in your numbers. Did the cost of the wood or the collection of the wood factor in either into time or money in the economics?
It actually did not. The way we interpreted our cost, we did it based on the opportunity cost, or how much money the farmers can make without or with their using the regular practices. So we did not incorporate that.
My question is, would you need one unit for a farmer, or could you have, based on the quantity of milk they're creating and the time it takes to process, multiple farmers share one unit?
So when designing it, it really depends on the throughput. Given the 2 gallons an hour, we'd estimate that it could probably service 2 farms at most. If we got that throughput higher, we would be looking at more community-based models.
You back there? Yes.
First of all, I'd like to say excellent job. One question, did you consider any automated or semi-automated ways for turning the drum so it wouldn't require an attendance?
We have, in fact. One of the concepts was to use a steam engine. However, the complexity and cost made it prohibitive to use in practice.
Tom?
When you tested the machine, did you test with raw milk or with grocery store milk?
So one of the things, when creating powdered milk, it has to be skim milk. So we were actually going with store-bought milk. The envisioned use of it would be to use a cream separator, or even just literally skim the fat off the top of the milk. The reason why it has to be skim milk is that the fat will actually go rancid in the powdered milk.
Did you consider the price comparison with commercial powdered milk that's imported from other countries versus what the farmers would be able to sell their powdered milk for, because it's not quality controlled?
Yes, actually, when determining how much money they could make per cycle, or how much they had, we used it as a percentage of that store-bought price. So we actually did about 20% of the cost, because it is not the same quality.
Question back there?
Did you consider the possibility that the farmers could manufacture this themselves out of components lying around, and what would the cost implications of that be?
We have. One of the major considerations is the pressure vessel itself. The pressure vessel operates at 50 psi, which in terms of steam systems is actually quite low. However, safety considerations just prompted us to have it manufactured in the industrial setting and then shipped to Guyana instead.
Question back there?
What are the changes that need to be made to the design in order to change to pasteurize the milk rather than to powderize it?
So that's an interesting question. We actually didn't look along that route, primarily because even when you pasteurize milk, it still only has a shelf life in probably around the 1 week range, especially when you don't refrigerate it, whereas powdered milk can last anywhere between 2 and 6 months. I'm not actually sure in the details of milk pasteurization.
We have a question in the front.
Did you think about maintenance? For example, if one piece of the part breaks, would it be easy to fix?
Yeah, definitely. So that's, as you can see, it's a very open frame, and actually a number of the components just snap on or even bolt on or off. We really designed it with the idea in mind that you could take out individual parts and service them as needed.
I think we have one more question here in the back.
Would it be possible to have multiple people pedaling at all? Are there different points of development you could do into the design to make that happen?
We don't necessarily see the need to actually have multiple people pedal. The pedaling itself is actually a very low power. It's very low power. It's very effortless. In fact, I wish you could invite you all up to jump on. But it's actually one of the easier parts of the system. I would actually even say that loading the wood might be the most strenuous thing to do.
I think we are done for questions. Thank you very much, Red Team.
I'm David Wallace, the course instructor. And in our first transition, we'll see how Red Team came to be.
Dum da da day, dum da da day, da da dee da. Pressure pushing down on me, pressing down on you. No man asks for. Under pressure that burns a building down, splits a family in two, puts people on the street. Ba ba bay, da da dum ba ba bay. It's the terror of knowing what this world is about, watching some good friends scream, let me out, praying tomorrow and get higher, pressure on people, people on the streets. Da-da-dee-da-day. Chipping around, kicking my brains across the floor. These are the days it rains but it pours. Da-da-dee-da-dee-da-dee-da-dee-da-dee-da. Da-da-dee-da. People on the streets. Da-da-dee-da-dee. People on the streets. Da-da-dee-da-dee-da-dee-da. It's the terror of knowing what this world is about, watching some good friends scream, let me out, pray tomorrow and get higher, pressure on people, people on the streets. Turn away from it all like the blind man sat on the fence, but it doesn't work. Keep coming up with love, but it's so slashed and torn. Why, why, why? Such an old-fashioned word, and love dares you to care for the people under edge of the light, and love dares you to change our way of caring about ourselves. This is our last dance. This is our last dance. This is ourselves. Under pressure, under pressure, under pressure, under pressure, under pressure, under pressure, under pressure.
All right, shake the rust off. It's okay. Sound all right.
Turning Japanese, I think I'm turning Japanese, I really think so. Turning Japanese, I think I'm turning Japanese, I really think so.
Let's give it up for Silver.
Good evening. My name is Alyssa. Katrina, Michael, and I, and on behalf of Team Silver, present to you Noribo, the interactive sushi delivery robot. When people dine out, they're looking for more than just great food. They want memorable experiences, and they're attracted to novelty. Meanwhile, restaurants are constantly competing to distinguish themselves. In sushi restaurants, some try to do this by providing boats or conveyor belts to deliver food to patrons, but our product seeks to deliver an alternative to sushi restaurants, but providing with a new robotic form factor. The Noribo would circulate around the restaurant, with each one carrying a small plate of sushi. Instead of ordering food from a waiter, the patron simply takes the plates off the passing robots. Let's take a look at this situation in action. At the beginning of the day, our waiter, Laura, takes a Noribo from the charger, turns it on, and places it on the bar. In the kitchen, our chef, Yoshi, is busy preparing delicious plates of sushi. When the plates are ready, he simply places them on the passing Noribo. We have a few Noribo here tonight, but in an actual restaurant situation, they can have up to as many as 50 to 100. From the time the patrons sit down, they see a variety of sushi passing in front of them, and they're able to take off as many as they want. Audience. The lights in here in Kresge interfere with some of the sensors that we have placed in our robots. We have tested this in restaurants where the infrared lighting is not a problem. But because we're in Kresge, we provided a short video to demonstrate this robot interaction. Once a plate is removed from the robot, the Noribo can respond in a variety of ways. As you can see, the Noribo, you can never tell how it will respond, therefore making it fun to remove food from the passing robots. As for the payment method, when the patrons are finished with their meal, they're charged by how many plates of food they've taken off, with each plate color-coded for a different price point. At the end of the day, the Noribos are wiped down and placed back in the charger for use in the next section. Now Micah will explain the design and engineering of the Noribo system.
Each Noribo has 5 infrared line following sensors on the bottom of the robot that allows him to navigate the restaurant on a track. Each Noribo also has an infrared sensor on the front of the robot so that he can detect stopped Noribo robots and other obstacles such as plates and glasses. If a Noribo sees something in its way, it just stops, waits patiently until the object leaves, and then continues on his way with your food. When we were designing the robot, we wanted to make sure that it was both aesthetically pleasing and that it conformed to FDA standards because it's going to be so close to food in the restaurants. After talking to industrial designers, we decided on a sleek, seamless look that was both appealing to the eye and didn't have any cracks or crevices for bacteria to lodge to grow and culture. The robot is also water resistant to protect the electronics on the inside, and you can also accidentally spill a drink on it, and Noribo will be just fine. The main chassis is going to be injection molded polycarbonate, and the lid to the robot is going to be a blow molded polycarbonate. Noribo is driven by 2 150-to-1 gear ratio micro metal gear motors. The robots can carry about 1 kilogram, which is 2 to 3 times the weight of the plate of sushi he'll be expected to carry. He travels at an optimum pace of about 8 centimeters per second, which is experimentally derived optimal pace for removing plates of food from moving objects. User interaction was very important to us when we designed Noribo. So with the plate detection, we're able to let the robots play sounds, flash their LED underglow, and do a little dance for you when you pick his particular plate of food. We also wanted to make sure that patrons didn't get a little overeager and try to take Noribo home with them. So each Noribo has an RFID tag on the bottom side of the lid, which will trigger an alarm when he's removed from the restaurant. It's important that Noribo can survive an entire lunch or dinner shift at a restaurant, which is why we have a battery life of about 7 hours and an ideal charge time of 1.5 hours. Our prototypes are relatively fragile, and so right now we're achieving charge times of about 5 to 6 hours, but with a more robust manufacturing and a more reliably assembly system, 1.5 hours is what these robots will be capable of. The robots can be charged about 500 times before the batteries need to be replaced by the restaurants, and they can all charge in parallel, which means we can put all of the robots in together and take them all out at about the same time. And now I'd like to introduce Katrina, who will be talking a little bit about our market for the robots.
Our initial market focus for this product is in Japan, where 20,000 new restaurants open each year. We've spoken to Japanese sushi restaurant owners, and we believe that Japanese diners would be especially receptive to the engaging technology of Noribo. Our primary benchmarking product is conveyor belt sushi, with over 3,000 of these restaurants currently operating in Japan. Conveyors have verified the market for our product and proven logistics such as the payment method. Noribo would be sold in packages of 10 robots with 1 charger for $2,000. A typical restaurant seating 60 patrons and using 100 robots would then be paying $20,000 for this average system. It's important to note that this price is less than half of the price for a conveyor system of equivalent capacity. With an initial business investment of $150,000, we expect an internal rate of return of 30% and to break even after obtaining 15 restaurants as customers in 2 years. And at steady state, achieved by year 3, we hope to have 20 customers per year. Noribo can achieve this market success because it addresses the needs of both patrons and owners. The automation and variety of the system allow restaurant owners to sell more sushi to more customers each day. The implementation of Noribo is simple. It requires only a contrasting line drawn on a flat driving surface. This gives freedom to restaurant designers. It allows them to develop unique and interesting restaurant layouts and dress up the aesthetic as they please. And the features of Noribo would be customized to reflect the theme of any restaurant. Shell colors, LED underglow colors, robot response tones, and printed logos can match the theme decided on by a restaurant designer. Noribo is an exciting new use for robotic technology. It reliably follows a line, constantly delivering sushi and interacting with the user. The Noribo platform will address the performance and aesthetic needs of the restaurant owner while delighting the wish for novelty of restaurant patrons. It takes a lot of people to build a small robot, so we would like to thank our instructors and the industry consultants we spoke with who helped us to bring you Noribo.
Thank you, Team Silver. Any questions? We have a question. Wait, okay. Barbara.
Have you considered the servicing of the bots, especially if they're located in Japan? And are there any replaceable parts that you could use as a continuing revenue stream?
So we modeled a lot of our robots off of the coaster pager systems that you see in a lot of restaurants. And typically the way those works, if something breaks, you can send them in, and they're all fully warranted, and the company just replaces them. So we imagine something similar with Noribo.
In the back there?
Yes. Did you consider the possibility of using a sneeze guard or splash guard for the food as it passes through several different areas?
It's something that's not currently implemented on conveyor belt sushi. It would also kind of interfere with reaching and grabbing the food. It's actually not something we'd considered, but it's something that could, with a creative mind, be implemented if necessary.
Okay, in the back there, Monica? Yeah.
How does the throughput of Noribo compare to a conveyor system? Looks like you're getting a lot more food on the conveyor system.
It's the throughput is actually quite similar to that of conveyor belts. Although the conveyor belt sushi has one plate on average of 1 foot or 1.5 foot on the conveyor belt, and therefore there would actually be probably more sushi per unit distance on the conveyor belt.
We have a question way in the back.
Can they be modified to hold more weight?
I'm sure with different motors, absolutely. Yeah.
The answer is absolutely they can be.
Okay.
Yes.
We have a question over here.
Have you calculated MTBF, mean time between failure for these?
Prototypes or mass manufacture? No, we haven't on mass manufacture. On prototypes, the ones that are manufactured and assembled correctly have quite a robust lifetime. The ones that aren't manufactured correctly fail very quickly.
Ethan?
What's the lifetime of, the conveyor belt seems like it could last much longer. Your lifetime of your product based on the battery alone would be less than 2 years, and so you'd have to replace. So do you have an easy battery replacement plan or program in place to make it competitive still with the conveyor belt system?
So, thanks for your question. So, I'll say two things. One is that the conveyor belt sushi actually has a very high maintenance cost associated to it, and when it breaks, it's actually the whole system that has to be dealt with by the restaurateur, as opposed to Noribo, where if one of the many robots fail, you just take it off the line, and then you can repair later, and it doesn't impede on the functioning of the whole system.
Peter?
I know the Noribo has onboard sound, and you said it just stops if it runs into an obstacle or it detects an obstacle. Shouldn't it make a sound?
We could consider that.
We have a question over here.
Yeah, who's the battery manufacturer and what's the battery technology behind the batteries you're using?
The batteries are lithium polymer batteries. And I don't know specifically who the manufacturer of those batteries are. I know which website we purchased them on. The batteries are 3.9 amp hours each. And the batteries we picked, we prioritized high charge density so that we could get long battery life out of our robots. We also wanted to minimize the height of the batteries because right now those are the object in the robot that's setting the height of the robot. And we wanted to keep it low and slim close to the table.
Okay, and we have one last question over here.
How do you control the speed of the robots, and have you thought about what happens when you have 60 of these things with slight speed variations all operating at once?
That has been considered right now. We're simply using a constant speed driven by the current to the motors. In future iterations, we could use an encoder to control the speed. If the robots start running into each other, they have sensors, so they'll stop, and it could cause a rubber band effect similar to traffic, but yeah.
Thank you, Team Silver.
Food is just like science, with tools that bend and baste, and every fun appliance gives the food a different taste. It's a piece of cake to bake a pretty cake. If the way is hazy, cook it by the book. You know you can't be lazy, never use a messy recipe. The cake will end up crazy if you do the cooking by the book. Then you'll have a cake.
Hello, my name is Ben Williams, and on behalf of Pink Team, I would like to introduce you to Spence, the Sensible Dispenser. Spence is a very simple design. He contains flour, and he measures and dispenses flour. So if you were to go to a store and look for something like Spence, you would find things that contain flour like this, and you would find measuring cups. However, you don't ever find anything that can really do both at the same time. So, some things that we designed for Spence. Spence can fit into different kitchen dimensions, like on a shelf or in a cabinet, as we have here, and he can also be moved down to the cabinet, onto the countertop, as Kim is demonstrating. And you can also move him onto the dispensing mode, Unfortunately, the stand is sometimes jams, as Kim is demonstrating now. There we go. Spence keeps our flour fresh by using a variety of seals. He fits large bowls, such as a KitchenAid mixing bowl. He dispenses into different fractions that are commonly used for flour, such as 1/8 of a cup up to 1/2 of a cup, and our maximum measurement is 1 cup, as Kim is demonstrating. So when we were using this and we tested it with other users, we found that there was an issue to where that when users tried to use it, they could sometimes overshoot. And it was hard for them to figure out whether or not they were at the right measurement. So we decided that we would institute a mechanical feedback system so that you can actually tell when you hit 1/8 of a cup, you're at 1/8 of a cup. He's also really disassemblable from the bottom so that you can easily take him out and wash him. And now, Julie, to talk about the technical stuff.
Thank you, Ben. All right, let's take a closer look inside Spence. So here you can see a cutaway view of the parts that are inside Spence. Now there are 2 main sections that you want to look at. First, we have the storage cavity. This right here, you can see that the flour is stored in this area, and we also have agitators inside that rotate to prevent flour packing. The next important section inside Spence is the measure mechanism. The way this works is it has 3 separate layers, the top and bottom of which are stationary, and the center one rotates. As the flour travels through Spence, it goes from the storage compartment through the hole in the top layer, it's rotated in the middle layer, and out the hole in the bottom. To make this a little bit more clear, we have an animation. As the user rotates the handle on the front of Spence to the correct measurement, it rotates the measure layer inside, exposing the measure compartments to the flour chamber. These fill with flour inside the chamber, and when the user is ready to dispense, they simply rotate the handle back to the beginning. The top layer levels those cavities, and the cavities are rotated around where the flour is able to fall out into the bowl. Let's take a little bit of closer look at some of the specific parts of Spence. So the key factor on the lid is the sealing O-ring. It's really important that the flour is kept fresh on your counter. You don't want any moths or other weird living creatures in your flour. So we have an O-ring as a seal. To fill Spence with flour, the user simply removes the lid and dumps flour in, as Kim is showing. The next thing that the flour encounters as it moves through Spence are the agitators. These are very important for 3 reasons. They prevent flour packing, they break up flour lumps, and they also allow us to fill the measure compartments accurately. Otherwise, we're not sure if we're getting the correct measurements. So you might notice that there are differently sized holes in the measure layer. How this works is that as they're rotated into the flour chamber, they add up to standard baking fractions that you might find in a common recipe. So I talked about how the measure mechanism is 3 layers. One of the biggest issues that we had in developing Spence was sealing against flour. Due to the very small grain size, flour is able to get in a lot of places, especially those places we don't want it to get. So in order to prevent it from causing a lot of friction in between the layers, we implemented what's known as a labyrinth seal. The black layers shown here are the top and bottom stationary layers, while the measurement layer is shown in white. There's teeth on the top and bottom layers that stick into grooves on the measurement chamber, the measurement layer, which prevents the flour from getting out through the sides and preventing a lot of friction. Ben mentioned earlier about a feedback system to allow users that they have gotten to the correct measurement. This is a very important part in user feedback. The bottom of the measure layer contains a spring detent which sticks into divots on the bottom of the bottom layer. Then as the user rotates the measure layer, there's a click so the user knows that they're getting exactly the right amount of flour. Ben also mentioned earlier that there are two heights for Spence. We have the dispensing height and we have the storage height. Spence is designed so that he will remain on your counter for most of the time in the dispensing height. But if for whatever reason, say it's Thanksgiving, you need your counter space, Spence is easily able to collapse down and go into the storage height. Now that I've told you about the technical details, Kim is going to tell you a little bit about the business side.
Thanks, Julie. So, because Spence is a consumer product, we decided that it would be best to sell it through the retail channel. For a brand new product launch, a conservative estimate of 150,000 units a year for a retailer is a good place to start, and from there we can grow. Our product retails for $35. We feel this is a good product price for our product because we did some benchmarking and found that it ranges from about $5 to $40 for a canister. This works well because our cost to produce is a little over $8.50, so there's a good margin for both us and the retailer themselves. We estimate we need a starting investment of about $600,000, and we break even in about 27 months. Over this time, we continue our research and development in order to make our mechanism work for other materials like sugar or spices. We've talked a lot about how Spence works, but let's talk about how stylish he is. Dressed in white and black, he fits any kitchen decor. His window tells you when to refill him, and he has a little target in his stand that lets you know where to put your bowl. We've had a lot of fun this semester, but we couldn't have done it without the help of all of these people, especially this past week when we've been in major crunch time getting Spence finished up. Thank you.
Thank you, Pink Team. We'd like to open up for questions. Any questions? We have one here.
Yes, I was wondering if you provided the possibility to expand to provide an option for sifting the flour that you produce out of Spence.
We actually did a quick survey online with Amazon Mechanical Turk and asked users how they actually measure flour, and we found that only about 20% are using a method that actually requires any sense of accuracy at all. Most people are either guessing, or they're kind of shaking it to level it, or they're maybe leveling it. According to King Arthur Flour, the correct method is weight, and so most users aren't even considering this and when they're measuring their flour. So no, we didn't consider sifting.
We have a question here.
Does the canister hold an entire 5-pound bag of flour?
Currently, it does not. Our tech review model actually did hold a 5-pound bag of flour, and a lot of the user feedback that we found was that it was simply too big, and people didn't want to have it on their counter. So I believe right now it holds about 3 to 4 pounds of flour.
We have a question in the back.
Hi, I have two questions as a user. Can you use any type of flour? Or is it just the white flour that you're using? Flours have different weights and densities. And the second question is, many recipes do flour by weight as opposed to American measures that you're using. Can this be adopted for other kinds of measures?
The mechanism we have currently is just a volumetric measurement system. We chose this because standard recipes for America have a volumetric system. And we've actually done some research, and a measured cup can weigh anywhere from 4.4 ounces to almost 5.5 ounces. And so you're getting a lot of variation. Volumetrically, it would work with any kind of flour, but you might not be getting the same weight that you would be getting with the white flour we're using here.
A question back here.
In the event that you go a little bit too far and you accidentally hit the cup mark when you really meant 3/4, is there anything that you can do to make up for that, or are you just going to have a little bit too much flour?
Essentially, in the event that happens, the user would likely replace their bowl that they're using to cook with, dispense into a different bowl, and put it back into the canister.
It's not ideal, but because our method is 2 steps, theoretically you would realize that you went too far before you actually dispensed any into your bowl. So you can save it.
Okay. Oh, we have a question up here. Maureen, and I think we're going to bring the microphone to you.
Oh, I don't want a microphone. What I want to know is what parts are
able to go into a dishwasher? Because let's face it, we don't want to wash this.
Right. I believe at the moment everything is able to go in the dishwasher. We have a few rubber seals that you would remove before putting in the dishwasher, but all of the plastic pieces would be able to go in.
It actually disassembles from the bottom, and so you can just take all the parts out and just put them in the dishwasher or wash them by hand and then put them right back in.
We have a question back here.
Yes.
Why did you choose flour? It's a multi-part question. What complications did you have using flour, and what complications would you expect dispensing other powders, sugar, what have you?
So we chose flour because due to the scope of the class, we found that it was simply too much to focus on multiple different ingredients and not do them all well. Yes, we focused on flour. Other ingredients such as sugar and other granulated items would cause a lot of problems getting in between the sliding layers and creating a sandpaper effect. So that would require a different solution. But we did find that with the current method, we would be able to dispense several other types of ingredients, other powders like convection or sugar, or we could even do rice, oats, coffee. I think we've all done all of those successfully.
Okay, I think that's all the time we have. Thank you so much, Pink Team.
In this class, we emphasize active learning, and in this particular example, it was with fire.
In this challenge, teams must create fire-starting machines which use only human power. Teams were given 10 minutes to design their machine, and the final designs selected from each team were Red's compression fire starter, Silver's hot wire cutter, Pink's rope friction starter, Blue's classic fire bow, Purple's hot wire and flour, Orange's compression igniter, Green's steel wool starter, and Yellow's Big Bang. Teams then had 1 hour to build their machines. The challenge rules are simple. Teams are arranged in Killian Court and compete in 2 categories. First to start fire, and best s'more.
The roof is on fire.
a burning thing, and it makes a fiery ring.
I'm the fear addicted, danger illustrated. I'm a fire starter, twisted fire starter. You're in the right, Eisenhower vaccine. England's got a new queen, Marciano Liberace, Santana goodbye. Alright, this goes on.
Oh my goodness.
You want that black stuff?
Hi, Mom.
Black's nasty.
You might not ever get rich, but let me tell you, it's better than digging a ditch. There ain't no telling who you'll be, a movie star or an Indian chief at the egg wash, working at the egg wash, yeah. Whoa, 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 whoa.
It's Blue Team.
Hi, I'm Brian Doyle, and this is the Happy Egg Washer. At the beginning of this semester, we were approached by Pete and Jen's backyard birds to help them expand their business. They were running into a problem. They could not clean all of their eggs in a quick enough amount of time. Currently, they were washing their eggs by hand and letting them air dry. And if they increased the number of chickens at their farm, they simply wouldn't be able to clean all of their eggs. We talked to several other farms from the area and realized that this was a much more extensive problem than we initially realized. In our research, we determined that there are 140,000 such farms in the United States alone, each with less than 3,000 chickens, and that there was a large need for a product that could clean these eggs quickly. That's where our product comes in. It addresses needs that are not specifically met by any other product on the market. The Happy Egg Washer can wash 800 eggs in a single hour and dry them. It is very easy to set up in a basement or in an outhouse, as it only attaches to a faucet or a hose, and it can also be plugged into a 120-volt wall outlet. Grace is now going to talk about some of the technical aspects of our project.
Thanks, Brian. I'm just going to give you a brief overview of the kind of technical features of our design, and Brian's going to demonstrate how you might actually use the egg washer. So the first step in using the Happy Egg Washer is to load the eggs into our custom designed tray. The tray is specially shaped so that the eggs are held in place to prevent breaking, and also are allowed to move around slightly so that they can be cleaned on all of their surfaces. So Brian's now going to load the tray into the machine. There are down sliders on the inside of the machine, which lock the tray in place, preventing any unwanted vibration during the wash cycle. And we're going to start the wash cycle itself in a few seconds. And we do this by using a very simple user interface on the side of the egg washer. It allows the user to start and stop both the washing and drying cycles, and also to choose between a heavy-duty wash cycle for very dirty eggs, which is twice as long as normal, and a light-duty for not-so-dirty eggs. So Brian's going to start the washer now. So as you can see, the LED screen is starting to count down the time. What's happening now is that a solenoid valve inside the machine is starting to spray water all over the eggs to loosen the dirt a little bit. And 2 cylindrical brushes parked at the back of the machine are now translating forward above and below the egg and spinning over the egg as they do that. What this actually does, we discovered, is that the bottom stiffer brush rotates the egg, making it spin on its axis, while the upper softer brush actually scrapes the dirt off the egg as all the surfaces are turned towards it. So in case you can't actually see what's happening from our demo right now, here's a picture of a lab test earlier. You see the brushes are coming towards the eggs. Yep, and the eggs you can see just starting to spin slightly there. And right about now, the brushes are going to kick back and clean the eggs. So this is all driven by an automation system, which is one motor connected to each brush, and these brushes are driven on a pulley system from both ends to prevent torsion by a motor at the back of the machine. The brushes are made of non-absorbent nylon, which means they won't absorb bacteria, but you will need to clean them because eggs get kind of dirty, so they're designed to be easily removable. Now Brian's going to stop the cycle. This is a safety feature of the device in case a user should accidentally try to open the wash cycle while it's running. We have everything automatically stop to prevent grievous bodily harm and nasty, dirty egg water splashing in your face. So normally what we do is we'd close the drawer and push the start button and resume as normal, but what Brian just did was to send the brushes back to the end of the egg washer by pressing the stop button so that he can safely take out the egg tray and put it into the drying compartment. As you can see, we've got a 2-compartment system, which is great for Brian because once he's put his eggs in the drying compartment, he could potentially put a new set of eggs in the washing compartment and continue going on in parallel. This means that he can dry and wash twice as many eggs as he would if it was a 1-compartment system. So the drying compartment itself is basically 4 fans mounted on the top of the machine, suck air down, pass through the eggs, and vent out the sides and through a hole in the middle. This basically pushes all the water down to the bottom of the egg. And this created a bit of a problem for us during testing at first, because however long or hard you run that fan cycle, there will always still be this tiny drop of water at the bottom of the egg because it's kind of a dead space where no air actually rushes past. The solution we designed for this is just a very simple roller at the top of the machine, which as the user pulls out the egg tray, as they would normally do, the eggs go over the absorbent roller, and the absorbent roller just takes off that little drop of water to make sure the eggs are completely dry. Obviously, they aren't in this case because we didn't run the fan cycle, but I'm sure you can use your imaginations. It would be very noisy if we did. So I'm going to hand over to Ian, who is going to talk a little bit about the market for this product.
Thanks, Grace. Let's talk business. So there are several egg washing products on the market today, but we feel that none of these effectively cater to the needs of the small farms which we have defined earlier. A couple of our competitors are pictured here. The first is the Cool Egg Washer. It soaks the eggs in a soap-water mixture. This is suboptimal because soaking the eggs allows for bacteria and fluids to enter the eggshell, which is an absorbent substance. The second product here is the Clean Egg Washer. And it's large. We feel that it's far too large. It cleans eggs with warm water. It sometimes even cooks the eggs, and it's also expensive at $7,000. We foresee farmers coming to us and purchasing our product for $4,000. What differentiates our product is that it uses less water, no soap, and it also incorporates this drying element along with the washing element. So a component of our business plan is to license out our technology, our designs, which include our custom-made brushes, our tray, and this egg washer, to a single egg washer producing manufacturer. This will allow them to expand their market, and it will allow us to avoid large initial capital fees associated with production. We anticipate initial costs of $100,000, which which include legal fees and patents. For revenue, we plan on having royalty costs of $240 per unit sold, and we also have an upfront fee to our licensee of $100,000 to cover our upfront cost. We anticipate a potential buyout of our company over 5 years, pending a gradual increase in demand and expansion of the Happy Egg Washer. So our sales forecast, we anticipated a 1% market penetration initially. We mentioned our market is 140,000 egg farms, so that's 1,400 units sold in the first year. We assumed 20% expansion in years 2 and 3 and 10% expansion in year 4. This leads me to our projected net income and valuation over our first 4 years of operation. We assumed a discount rate of 30%, which is high because this is a relatively new venture. We also assumed a target price of $4,000 to the farmer and a unit cost of $1,000, which is actually conservative based on our analysis, which concluded that it's actually going to be more on the order of about $600. Our net present value, thus, is slightly over $1 million. And this concludes the formal part of our presentation. Finally, we'd like to thank everybody who made the Happy Egg Washer possible.
Thank you, Blue Team. Any questions? Sorry, we have one right here.
Are you able to use a battery instead of using the outlet?
Sorry, could you repeat the question?
Can you use a battery instead of using the outlet?
Potentially, actually, I think you probably could. Is that?
So we would need to actually change the fans inside the machine, which are actually running off the outlet. But since everything else in the washer is 12 volts, you could use just a car battery for everything else. And I'm sure that with just looking for fans a little bit, we'd be able to make a battery-operated model pretty quickly.
We have a question back here. Sorry, and then we'll.
Have you considered using the wastewater as fertilizer?
Yes, we have. We've got a drain collection in here, which you can't really see it now because these weren't very dirty eggs that we just washed, but dirt collects there, which you can collect as fertilizer, and you can also just drain the hose into a bucket, and yes, it has been suggested that we use that as fertilizer, which would be great. It's very good fertilizer.
We have a question in the back here.
Hello. Most small farmers don't have the luxury of choosing the optimally sized eggs that you find in supermarkets. Does this machine compensate for different sized eggs?
Yes, we actually tested with both large and small eggs. Obviously, there is a slight limit, but we did test originally with the eggs from Pete and Jen's Backyard Birds, which were very varying in size.
Question here?
I have two questions, actually, or maybe two parts. How many eggs were broken to get to your final product? And if the farmer puts in a tray of eggs and there is a crack or one breaks, what happens to the inside of the machine and how do they clean it?
To answer the first question, I think you'd have to ask our next door lab mates Yellow Team, because there were several projectile eggs at the beginning of the development process that may or may not have gone in their direction. Does anyone else want to talk about the cleaning facility? Yeah.
Yeah, sure. If any egg were to actually break inside the machine, it's a very watertight compartment, and that was a big challenge in our design. So actually, we'd be able to run the rinse cycle, which sprays out at a 45-degree angle, and probably clean the entire inside. Not to mention that there's actually pretty easy access if you actually had to scrub to some extent.
We have a question back there.
Hi, yeah. So first question is, how 100% clean do the eggs need to be in order to sell them? And second, how 100% clean does your machine get the eggs? As in, if I thought about it and if there was some dirt left on it and that wasn't market acceptable, then you might have to go back and clean it by hand a little bit anyways, which might significantly reduce your throughput.
Right. So we do have two cycles, kind of a light duty and a heavy duty. Light duty being for kind of regular dirt, and heavy duty being for things like broken eggshells. The customer that we talked to, actually, his customers weren't that bothered about the eggs being very clean. And I think kind of also in an organic farm market, you're not looking at trying to bleach the eggs or anything like that. But it does, I think if the user knows that they've got some very dirty eggs, then they can use the heavy duty cycle, and that's why we incorporated that feature.
We have another question here.
How many eggs can you fit in the washing or drying?
36.
Okay, and we have time for one last question back here.
How much labor does the egg washer save the farmer, and what's the ROI to the farmer in terms of that labor savings?
Sure, yeah, I'd say the major benefit of the system is that the farmer can probably wash on the order of 300 eggs in an hour or so. However, doing that repeatedly would be pretty exhausting if they were doing it manually. What this system allows them to do is not only to wash 800 eggs, but it is a lot less energy in just loading the eggs into the tray and whatnot. So although we notice that it's not maybe a huge gain in a single hour, for a sustained amount of cleaning, it would definitely be a huge gain.
Also, another thing with the cycle time of the machine is that while it's running, you can actually box the eggs that you've just got out of it. And that's a process that, and when we went to Pete and Jen, what they did is once they washed the eggs, they waited for them to dry before boxing them. So in this way, you can even incorporate that into the same time that you'd be washing and drying the eggs. So it does actually save a lot of time.
Okay, thank you so much, Blue Team.
We have the good fortune of a lot of outside support for this class, so we'd like to say thank you.
So no one told you life was gonna be this way. The job's a joke you broke, love life's your way. It's like you're always stuck in second when it hasn't been your day, your week, your month, or even your year. But I'll be there for you when the rain starts to fall. I'll be there for you. I've been there before. I'll be there for you, 'cause you're there for me too. You're still in bed at 10, work began at 8. You burned your breakfast so far, things are going great. Your mother told you there'd be days like these, but she never told you that the world would bring you down to your knees. But I'll be there for you when the rain starts to pour. I'll be there for you like I've been there before. I'll be there for you, 'cause you're there for me too. No one could ever know me, no one could ever see me, 'cause you're the only one who knows what it's like to be me. Someone to face the day with, to face all the rest of it. I'll give you all and tell you, even at my worst, I'm best with you. It's like you're always stuck in second gear when it hasn't been your day, your week, your month, or even your year. But I'll be there for you when the rain starts to fall. I'll be there for you like I've been there before. I'll be there for you, 'cause you're there for me too. I'll be there for you when the rain starts to pour. I'll be there for you like I've been there before. I'll be there for you. You're there for me too. Nobody told me life was gonna be way. A child's a joke you broke, love lies to your way. It's like you're always stuck in second gear, when it hasn't been your day, your week, your month, or even your year. I'll be there for you when the rain starts to pour. I'll be there for you like I've been there before. I'll be there for you 'cause you're there for me too. I'll be there for you when the rain starts to pour. I'll be there for you like I've been there before. I'll be there for you 'cause you're there for me too.
We have one special final thank you to the creator of the lab that we've come to know and love, Neil Pappalardo. Neil.
If you need milk or if you need bread, then there's a place where you should head. At the supermarket, you can buy everything when you do your grocery shopping. At the supermarket, you can buy everything when you do your grocery shopping.
Let's have a big round of applause for Purple Team.
To many of us, this is a familiar sight. It's the aisle of your local grocery store. However, for many wheelchair users, this can represent difficulties and challenges. One of these challenges is simply transporting your items from the aisle to the front of the store and ultimately to your vehicle. Hello, my name is Megan Roth, and I'm a member of Team Purple. This year, Team Purple decided to take on this challenge, and we designed and built the Grocery Mate. The Grocery Mate is an attachable basket for rigid wheelchair users that allows them to easily go through the grocery store and transport their items. Our product was originally inspired by the story of Colleen Rock. Colleen is a freshman here at MIT, as well as a member of the U.S. National Sled Hockey Team. She's going to share a little bit of that same story with you tonight.
So occasionally I go grocery shopping, and I usually end up using a cart. This is me sad with a cart. And the problem with the cart is it gets in the way, it's heavy, it leaves painful marks on my legs after being filled with groceries. And so sometimes I use a cart. Oh, that was a basket. This is a cart. Also difficult to push around. It's bigger than me, so it's kind of intimidating. And then someone once asked me if I ever used one of these things, and I kind of laughed, and I said, why am I going to leave my expensive custom wheelchair in the front of the store where it can be stolen just so I can use something that's even less maneuverable than a cart? The problem is, with any of those things, is none of them helps me get my groceries to my house after I've checked out of the store.
As you can clearly tell from Colleen's story, there's a need and a want for the Grocery Mate, which nothing on the market even comes close to filling. Right now I'm going to hand it over to Sun, and he's going to tell you a little bit more about the technical aspects of the Grocery Mate and why we think it's such a great solution.
Thank you, Megan. Here are some of the key design elements of the Grocery Mate. We designed the clamps so that users with limited dexterity can easily latch and unlatch the clamps to the wheelchair frame. Our clamps have a large interface with the wheelchair for ease of attachment. The low vertical post remains out of the way and does not interfere with the natural range of motion of the user. Wheelchairs have many different designs, and one of our biggest challenges was to accommodate for the different angular configurations of the front wheelchair frame. And we do that with a customizable part that accounts for the variable angle between the wheelchair frame and our clamps. The steel support frame locks to a second tube that is attached to the clamps. When the user first configures the Grocery Mate, she can adjust the frame 3 inches horizontally, 4 inches vertically for her comfort. These mechanisms resemble familiar wheelchair features so that the adjustment process is intuitive for the user. The swivel has a large range of motion. When she wants to open a freezer door or reach for low or high shelved items, she can easily push the basket out of the way. Spring detents lock the swivel mechanism while the wheelchair is in motion, while the swivel can be easily disengaged with the push of the basket. Hard stops prevent the basket from overturning and inadvertently hitting the user or other people. The basket slides onto the frame, which has a wear-resistant sleeve over a steel tube core. When the basket is in place, a spring-loaded latch automatically locks the basket to the frame. The basket is collapsible, lightweight, and easy to store, but can securely support over 40 pounds of groceries, more than a traditional shopping load. Our surveys indicated that the average weight of purchased groceries in a traditional shopping basket was only 15 pounds. The basket, once collapsed, also doubles as a utility tray, for example, a cutting board tray for cooking, or a tool tray for do-it-yourself projects in the garage. We designed the Grocery Mate to weigh only 7 pounds. This includes all 3 components of the Grocery Mate: the aluminum clamps, the adjustable steel tube support frame, and the basket. Here's Emily to talk about the current market and our financial plan.
Thank you. The Grocery Mate targets users of manual rigid wheelchairs, or in other words, the non-automatic, non-collapsible wheelchairs. This market has been growing at 12 to 15% every year, and we therefore believe that we have a sustainable market to tap into. In the US alone, there are 3.3 million wheelchair users, and we estimate that about 400,000 would be target customers. The marginal cost was calculated based off of manufacturing costs, labor, and raw materials, and came out to be $80. However, we would sell the product for about $200, which we believe is a reasonable estimate based on user feedback testing. The Grocery Mate would join the wheelchair accessories market, a market that has a revenue of about $20 million a year. We would hope to capture about 6% of that market. Other products in this market include things like add-on wheelchair desks or add-on wheelchair trays. But as you can see, there's no Grocery Mate up there yet. Finally, based on the enthusiastic responses from feedback testing at the Boston Home, Spaulding Rehabilitation Center, MIT, and Lincoln Labs, we believe that we have an extremely attractive product. First of all, when they're at home, users are able to adjust it according to their chair and to their needs. At the grocery store, our product has the same capacity as a store basket and allows users to still easily maneuver through the aisles by not increasing the footprint of the wheelchair. When users get home, they're able to collapse our lightweight basket into itself for easy storage, or leave it on the wheelchair in the tray form to use it as a tray. With all these features in mind, we believe that we have an extremely compelling product.
As you've heard from Emily, there's clearly a need and a want for our product, and as Sun explained, the Grocery Mate meets all the features that users need today. We feel like going forward, the Grocery Mate would be a viable option in the market. Future iterations could possibly include additional handles on top of the basket, as well as a shear pin, so in case a young child jumped on it, it would snap off instead of tipping over the user. We'd like to give a big thank you to the people that you see behind me for all their extraordinary help in making the Grocery Mate come true. And we'd also like to give a big thank you to you, the audience. Thank you.
Thank you.
Thank you, Purple Team. We'd like to open it up for questions. Yes.
You said your clamp can accommodate many different wheelchairs. What's the clamping range in terms of diameter, and how much deviation from vertical can you accommodate with this product?
So one of the main things that actually comes out, and one of the biggest problems, is that there's a wide variety of wheelchair tube sizes. They range anywhere from 1 inch to 1.25 inches. And while our clamp actually doesn't accommodate all of those ranges, we've identified the 3 or 4 main components that would need to change in order to accommodate for each of the different size tube diameters. In addition to that, one of the finishing operations is a simple drilling operation that is used to match the different angles of the wheelchair.
We have a question here.
Could you please explain to me what happens once you leave the grocery store with the groceries and how you get the basket off and get it into the car?
So Colleen can actually demonstrate taking off the basket, and you can watch her here. The cool thing about the Grocery Mate, as opposed to other things on the market, you can sit on the table if you want, is that the Grocery Mate is owned by the user. So that way you can load it up into your car. Colleen also loads her wheelchair into her minivan by herself. So the Grocery Mate would go home with her. When she got home, she could reattach the Grocery Mate and take all of her items inside in one trip instead of having to make multiple trips as if she had used the basket at the store.
Do we have other questions? Oh, here, we have one in the front here. Well,
I forgot.
What about stability? Two-part question, I guess. Stability and is there a latch that is secure under all circumstances that prevents the thing from swinging out to the side?
So we employed, in addition to the spring detents to hold it in 2 90-degree locations, there are hard stops as well. So Colleen can't actually push it any further than it currently is. And in research with users and Colleen specifically, it just, given the 40-pound weight limit that the volume of this basket limits us to, there isn't enough moment for the wheelchair to tip sideways or forward.
we have a question in the very far back.
Hi. I was just wondering what made you choose to go with the design, to design the basket yourself as opposed to using the standard basket that you find in most grocery stores?
We chose to design the basket ourselves because it needs to lock into the support bar, and so there is a special groove that we designed for that that makes it more stable so that the load is distributed more evenly. Also, we chose to make the basket collapsible, and that's not found in the standard grocery stores, and the reason for the collapsibility is so that we can use it not only as a basket, but as a tray, and it makes storage a lot easier.
We have a question in the back here.
Hi, I was just curious, when the basket's full of groceries, like if it had, you know, the 15 pounds or whatever in it, how easy is it, especially, I understand the user now is young, but how easy is it, for example, like a more elderly person that's in a wheelchair to slide the basket sideways? I gotta keep this close to my face. Slide the basket sideways to get it off of the post that it's being held with?
So the basket slides off pretty easily.
Yeah, it's really easy to slide.
On the same note, if you bagged your groceries and put them into the Grocery Mate, you could always just unload the bags into your car and then add the Grocery Mate as a simple, secondary step. So it would be just like unloading another bag, which means you wouldn't have to pick up all of the groceries.
I think that's all the time we have for questions. Thank you so much, Purple Team.
When you're feeling sad and low, we will take you where you gotta go. Smiling, dancing, positivity. Cover to the world, every boy and every girl. People of the world, go round. Cover to the world, every boy and every girl. People of the world, I see ya, hold tight.
Let's hear it for Orange.
My name is Kevin. On behalf of Team Orange, Emily and Amy, I bring to you our product Dash. Dash is an in-store spice dispensing unit that dispenses spice in small individual units, in blends, or by spices themselves. The product will be marketed to spice retailers, and tonight we're going to be discussing about the need of this product, beginning with the use of the product itself, moving through the technical advances of the product, and finally onto the market. So what exactly is Dash and how is it used? If you go into the grocery store and you're trying to decide what to cook, you might have a dish such as chicken or beef in mind, and you're trying to figure out a way that you can really spice it up. You can look at different recipes, different spices, but what a user will do when he approaches a machine is if he knows what spices he wants, he can select them individually, or the machine itself can give him a recommendation. So as you can see here, going through on the screen, you can choose which spices, or again the selection. And then once the user confirms it, the machine will ask him if that's the selected spices. And then up top, the carousel, which contains 15 spices, will rotate and deposit the spices into the cup pay below. Along with the spices in the cup, the user also receives a receipt, which if he does individual spices, will have the list of the spices in there and their amount and cost. And if he does a recipe, it'll include the directions for the recipe, including the cooking nutritional facts. So the current market for spices, there's mainly two ways that users can purchase spices. The first being in a typical grocery store, where you're forced to buy a large bottle at a higher rate. Now the advantage of Dash is, if you want a small amount of a spice, you don't have to buy a large bottle. So if you're cooking something that you do once a year, you don't have to buy a $5 jar if you just need a 1/4 teaspoon or 1/8 of a teaspoon. This prevents you having a kitchen cabinet full of spices that lose freshness and over time just clutter up your kitchen. The second choice for buying spices is at a larger specialty mart where you can scoop them out of a large container. This gives you a choice in the amount of spices you're selecting. However, there's mess and there's also contamination issues with this. Our product Dash not only eliminates this mess, but it allows there to be a larger market base to introduce customers willing to use spices thanks to our useful suggestions and recipes. Now in our research, we worked with people from Whole Foods, McCormick Spice Company, and our own local harvest co-op. We received some good feedback from them. John Mackey, the president, CEO, and co-founder of Whole Foods, said he saw the benefit of this product as an opportunity to expand the overall spice market. Our work with Harvest Co-op provided us valuable feedback in the areas of customer needs, pricing concerns, and overall store logistics. And finally, James Lynn from McCormick Spice Company said he could see a need for this product overall in the market of spices. Next, I'll be passing off to Amy to go over the technical part of our machine.
Throughout the development of our product, we focused on 3 main technical innovations: dispensing, collecting, and the user interface. For dispensing, we wanted to be able to consistently dispense a fixed volume of spices of various textures. The final mechanism we ended up using uses a glass jar as a hopper. Spices fall down into the dispensing mechanism to fill a cavity on a rotating drum. As the cavity rotates downward, the scoop of spices falls out. An agitator ring is coupled to the rotating drum through gears so that various textures of spices, like powdery spices like cinnamon or leafy spices like parsley, can all be dispensed. Next, for collecting, we wanted to be able to quickly and efficiently get the spices into the final collection container. But we wanted to do so without any risk of cross-contamination between different spices. We also wanted users to be able to see what was happening in the machine. After trying several mechanisms, we picked a carousel design, where the collection cup itself is fixed. The spice dispensers themselves sit on a rotating turntable actuated by a centrally mounted gear motor. An encoder on the motor helps position the dispenser directly over the collection cup so that spices fall down and there is no risk of cross-contamination. In addition, the individual spice modules can easily be removed for replacement or refilling. Finally, we developed an intuitive user interface that allows users to select the spice blend they want in 2 different ways. If the user already knows what spices they want, they can directly input those spices and the desired quantities, or they can browse recipe selections from the machine itself. Our current selection of 15 spices were chosen based off of looking at sales data from Carver's Co-op of their most commonly sold spices. We also analyzed a wide range of different recipes. For the recipe selection, users can choose the recipe they want by picking their main ingredient, their course, or their type of cuisine. After a recipe has been selected, users can then specify the number of servings they want. Finally, the overall order can be reviewed before purchase. In addition to dispensing the blend itself, Dash also prints a receipt with the full recipe and list of ingredients.
Now that we've understood the market need and the technical innovations, let's take a look at the business opportunities. The current spices and herbs market is about $1.4 billion and is anticipated to have steady growth in the coming years. Companies like McCormick have seized this opportunity by creating products like Recipe Inspiration, a product that packages small quantities of spice blends in order to introduce consumers to new flavors and recipes. Within just past 6 months, the recipe innovations were able to increase revenues by about $6 million for McCormick and have proven to drive spice sales. The success of Recipe Inspiration illustrates that now is a good time for Dash to enter the market. Within the value chain of Dash, there are 3 points where we can gain profit. The first is by selling the actual machine, the second is servicing the machine, and the third is by marking up the spices sold within the machine. Initially, our team analyzed the most economically conservative and simplistic business model, which is just to sell the machine for a profit. However, we do understand that if we were to do future business iterations and business models, we can incorporate both the servicing and the spices. Then using this business model, let's take a look at the first year. We anticipate the unit cost production to be about $3,000, and then the overall annual company operating costs to be around $380,000. After considering these costs and then consulting industry experts, we came up with an initial price tag of about $9,000. We expect this price to decrease as production increases and efficiency improves. Then, in order to understand the feasibility of a long-term company, we made a 4-year projection of the sales and operations. Initially, we'll target niche grocery stores and smaller distributors because of their flexibility and willingness to experiment with more innovative products. We do expect sales to increase, however, as the product proves to be successful and companies see and take buy-in into our product. That will lead us to a break-even point around year 3 and a 4-year internal rate of return of about 24%. Ultimately, Dash is an innovative product that addresses a clear market need and presents a terrific business opportunity. Dash, truly a revolution in spices. Thank you.
Thank you, Team Orange. Any questions for Team Orange? We have a question back here. Monica?
Heather, is there a discrepancy between you fill the machine with common spices, but you're trying to introduce more unusual spices to the public?
So currently there are some constraints in the size of the dispensers themselves. Over the scope of the course, we weren't able to make them as compact as we want. So currently it holds only 15 spices, but we envision that the dispensers themselves could be easily made more compact to accommodate a wider selection of spices.
And, sorry. Yes, sorry. Thank you, Rich.
Have you considered interfacing with other websites such as allrecipes.com or likewise so that users could submit their own recipes and pulling the spice blends from that?
Yeah, so that is something that we thought about and considered, but due to the time constraints, we weren't able to actually connect it to a network to pull off of websites. But that is something that would be very useful for this product. And also we considered actually collecting data for spice manufacturers just to see which spices are dispensed more often.
We have a question here.
Yes, is there any problem of spices contaminating each other, like red pepper, getting mixed in with cumin?
So Currently, the dispensers, each one contains a separate spice, and the spice, when it's dispensed, falls downward directly into the cup that collects it, so there is very little risk of contamination between different spices.
We have a question over here.
I feel like restaurants make a lot of their money selling more spices to people than they necessarily need. So you'd end up buying like a large jar of spice instead of the small amount that you'd like, and then you end up buying more from the store when you lose or
So the idea
something
behind,
happens.
yeah, that makes sense. But first of all, consumers are not happy about that. It's not like they want to do that. And the second thing is this actually increases the customer base because people who would be hesitant to buy spices because they otherwise would have to purchase a large bottle or they just don't know what spices to purchase, this machine kind of educates the consumers about what spice blends they can use using the suggestion option. And let's say a consumer finds a spice blend they really, really like, then they can go to the grocery store and purchase those spices, therefore actually increasing sales for spice distributors. Otherwise, they wouldn't have bought them to begin with.
We have a question back here.
Do you foresee a bottleneck with the user interface? Do you think that you'll need more than one of these machines in bigger supermarkets, or do you think it'll be fast enough throughput?
As of now, we've designed the user interface to be as quick as possible, and at least when I go in the spice aisle, I don't generally see tons of other people in it, so it's definitely something that we would need to test out and see in the future.
We have a question back here.
You said about selling the spice by weight. Is there a measurement of how you're going to be, is there a scale, I should say, how you're measuring out how much each spice is in there?
So currently the spices are actually dispensed by volume. That's normally how we found the measurement in all the recipes we looked at. In addition, we felt that it was unreliable to find a scale that actually could read down to the resolution of the weight of spices that we're measuring.
We have a question here.
So am I just supposed to carry around a cup, or is there like a closable container?
Yeah, there's actually a lid that goes on it, so you don't have to hold a steady hand. We got you covered.
We have one last question back here.
Is there a feature in the machine that alerts the store owner when one of the jars is empty?
Oh, okay, right. So, yeah, we actually did consider this, and for our product, we would we envisioned using some kind of sensor to tell if the spice jar is becoming empty. Right now, what we're using is we're just keeping track of how much the dispenser actually dispenses, and then once it thinks that it's getting low, it'll alert the store clerk.
Okay. Thank you so much, Team Orange.
When you walk into any store, you'll pay $1 or even more for water, bottled water. If my grandpa was alive today, he'd think that we were nuts to pay for water, bottled water.
It's the Green team.
Good evening, ladies and gentlemen. My name is Heather McDonald.
My name is Vibin Kundakulam.
And I'm Carolyn Hanaveyman. And we're proud to present you with Rensa, the water bottle washer and filler, targeted at fitness centers. So your first question is, why wash and fill water bottles to begin with? Well, Americans throw away millions of tons of plastic water bottles every year, and the simple solution to that would be to get people to use their reusable water bottles that they already own. However, we all know that reusing reusable water bottles is very inconvenient. From trying to fill them at the water fountain to trying to clean them by shoving your hand down in, and it never ever fits. We've all struggled with that, and hence we've created Rensa to try to solve that problem. I'd like to call our friend Patrick now to demonstrate how Rensa works. As you see, Patrick has a nice dirty water bottle, and he's going to use Rensa to clean it. He opens the door, flips the bottle upside down, and places it in the clamping mechanisms and closes the door. By pressing the button, he's able to start the wash. Rensa right now is washing Patrick's bottle with hot, soapy water. Patrick, why don't you try to test the safety feature? See as Patrick tries to open the door? Our door locks to protect Patrick and any other users from the hot water inside the machine. After the washing cycle's over, the locking mechanism will unlock the door and allow Patrick to open the door to get to his nice, clean bottle. The washing process takes about 30 seconds, which is a much shorter time than I'm sure you'd spend at the sink trying to get this thing cleaned. It also completely sanitizes the bottle, decreasing the bacteria count within it. Now that the bottle's washed, Patrick's able to take his nice, clean bottle and fill it quickly on the filling side. It takes about 12 seconds to fill this 1-liter bottle, which is a third of the time he'd spend at a water fountain trying to fill it. It's also much easier to use because you're able to hold the bottle vertical instead of tilting it at an odd angle. Now that Patrick's got his bottle filled, he can quench his thirst. Thanks, Patrick.
Now let's take a look inside Rensa to see how the product works, starting with the washing side. First, water goes through a heater, which you can see highlighted in green. Water needs to be heated at a temperature of over 170 degrees Fahrenheit in order to kill bacteria. Rensa heats water to over 180 degrees Fahrenheit, which is more than sufficient to kill any bacteria that may be present on a bottle. Next, the hot water mixes with detergent. The mixing is accomplished by the Venturi effect, in which a very small amount of detergent is released into the hot water line. By regulating the signal to the solenoid valve, the size of the tubings, as well as the settings for the chemical injector, we're able to release that very small amount of detergent that's necessary for washing bottles. Rensa uses a total of 1 milliliter of detergent per wash cycle, and the container itself holds a month's worth of detergent. Finally, let's take a look at the washing process itself. Rensa uses approximately 2 liters of water to wash each bottle. This is about half the water you would use if you were to wash a bottle by hand. Inside the wash chamber itself are clamps. These clamps hold the bottle firmly over a ring of nozzles. In order to clean the dirtiest parts of the bottle, these nozzles are oriented to point both inside the bottle as well as at the threads on the bottle's neck. We recognize the importance of making Rensa compatible for all sizes of bottles. That's why these clamps are designed to hold bottles ranging from 2.5 inches in diameter all the way to 4.25 inches in diameter, which are your extra wide Nalgene bottles. We ran sanitary tests to confirm that our wash cycle was indeed killing bacteria on these bottles. As you can see from the slides, over 99% of the bacteria were killed by the combination of hot water and detergent. Now let's jump over to the other side of Rensa and look at its dispensing process. Our chiller cools water to less than 55 degrees Fahrenheit, which is actually cooler than your standard water fountain. Because of its high capacity, Rensa can dispense over 40 liters of chilled water per hour. The cooled water then goes through Rensa's filtration system. In order to accommodate high flow rates, we use 3 filters set up in parallel. These are quick change filters, so they only require 1 minute to replace the entire system, which you would do approximately once every 6 months. Finally, the cooled filtered water goes to the filling chamber, which is what the user interacts with. We realized that tactile feedback was very, very important for users, which is why we designed a lever for users to push their bottle against to begin filling. Rensa can fill a 1-liter Nalgene bottle in approximately 12 seconds. That's 3 times faster than a standard water fountain.
The electronics are the brain of the machine. A custom printed circuit board actually operates all of the valves, enhances our product with safety features, and does some and makes our project more energy efficient. Currently, there's a toggle switch that a maintenance worker can use to shut off the entire machine, so that overnight we're not running the heater and the chiller and consuming extra energy. As we look around at the back of the machine, we can talk about how easy Rensa is to install in a fitness center. It simply plugs into your average 120 volt, 20 amp outlet, and uses the 60 psi that's already the pressure of the water within the walls. While we were working on making Rensa easy to install, we also focused on making it easy to design for manufacturing. Using the processes listed up on the board, you can create the entire structure, the facade, and even some of the smaller pieces like the clamps and the lever if you were to produce this en masse.
Our primary target will be gyms. The fitness industry in the U.S. is currently $24 billion, and it's growing at a rate of 3.3% annually, despite economic conditions. There are 32,820 establishments across the nation that we plan to target. On average, the average gym member is between 25 and 44 years old. And through our research, has shown that it's over 50% bring the reusable bottles, which fits nicely into our trendy, eco-conscious user profile. The gym market is highly competitive, so it's very important they're able to offer unique services. With many of our contacts that we talked to, they've been very interested in being able to provide this for as an additional service for their members. Currently, there exists nothing in the market like Renza that both washes and fills your bottle. But to get a sense of what the water dispensing market looks like, here's your average water fountain that ranges between $500 and $2,700. The one to the right you can actually see at multiple locations at MIT. This is actually a standard, these are some standard bottle fillers. We therefore think it's very reasonable to be able to sell our Renza at a retail price of $3,000. And because we're offering a unique and incremental value of washing the bottle above just dispensing. So we want to sell this at a wholesale price of $2,200 to water system distributors in order to decrease our maintenance fees and our expenses. We project that we'll be able to sell around a little over 2,000 units in the year of 2015. And this is based on reaching a market penetration of 7% by the year of 2015. 7% is feasible as many of the gyms are franchises that would be able to offer this as a standard service throughout their establishments. As our sales increase, our cost per units will naturally decrease. The manufacturing cost is based on outsourcing manufacturing, and the expenses account for interest expense, returns on sales, wages, rent, and taxes. With an initial investment of $750,000, we project that we can have net earnings of around $1.2 million in the year of 2015. And we can break even in year 3. As we saturate this market, we hope to expand and look into secondary markets such as offices and schools.
In summary, Renza is a product that washes and fills your water bottle so that you can use your reusable bottle more conveniently.
It's been a really amazing experience working on Renza throughout the semester, but we could not have done this without an absolutely incredible team of mentors.
And we invite all of you to come to our booth after the presentations to try out Renza for yourselves. Thank you.
Thank you, Green Team. Any questions? And I see we have one right back here.
Do you rinse the water bottle after it's been washed? I'm concerned both about soapy residue and also the high temperature water bottle. You may get people getting burns if the bottle stays hot.
So the rinse cycle, or the soap cycle, is for 2 seconds, and then the bottles get rinsed afterwards, and we actually tuned the soap so that it does completely get rid of all the soapy water. And there's a lock on the door so that you will never get burned from the hot water, and when the bottle comes out, it's warm, but it's not too hot to touch.
Question back here.
Have you done anything to address the potential sanitation issues of someone filling it with a dirty bottle that they might not think it's dirty, like something that they brought from their home, just filling it on the fill side?
So while they're correcting this the question was about somebody filling a dirty bottle. If they would choose to fill their dirty bottle with the filler, it would be the same as if they chose to fill their dirty bottle at a water fountain. But there shouldn't be any, because our device only touches the very outside of the bottom outside of every bottle, the same way that a soda fountain lever touches the middle outside of a cup that you use at a soda fountain. There shouldn't be any major cross-contamination issues.
A question back here.
Yeah, so this wouldn't be applicable in a school or a gym, but for the question I'm asking, but I was wondering if this has a cleaning capacity to clean things like old pickle jars that you want to reuse for something else?
So our washing chamber is actually designed to hold bottles of any size. There is actually a diameter limit of about 4 inches, and there's a little bit of a height limit, but potentially it could wash out old pickle jars if you wanted it to.
We have a question back here.
So would this be a paid service? Because I'm wondering, as in, how would a gym profit from using this in their gym? As in, most people will go to a gym because, you know, the gym is like a really legit gym, so they'll want to go there for its services. So will the gym have to do like a coin dispenser, so you have to put coins in to use this so that they can actually make money from?
So the idea is that the user wouldn't have to pay for this because the gym would be offering this as a service, so they would basically cover those costs, just the same way as they cover the cost of you being able to use their water fountains or you know, things that that quickly dry your bathing suit at a pool. Things like that are all services that the gyms would pay for.
We have a question back here.
Yeah, I've got a lot of water bottles at home, and they all have different funny kinds of lids. What about the lids?
So the lids were actually a pretty difficult problem to tackle, and we were hoping that if you have your protein shake and whatnot cleaned out of the bottom of your bottle, that's a big issue, getting your hand inside there. Your lids are something you can wash with your hand, and it was honestly something that we couldn't tackle immediately. So we worked at something that would really do something that you couldn't do by hand and do it well.
Okay, one last question here.
Hi. First of all, thank you for the energy efficiency. Loved it. I'm wondering how the electricity use compares with Rensa as opposed to like washing it yourself and filling it yourself, like the water fountain and also like whatever faucet electricity use there is.
At its maximum use, it'll pull about 1.5 kilowatts, but when it goes into its nighttime mode or something, it'll basically pull no energy at all. But over time, it uses about the same as a standard 2 drinking fountains that have 2 chillers in them. And as far as water usage, I'll let you.
Okay, so for water usage, washing it by hand, we tested, takes about 3 liters of water, and that's mostly because you leave the faucet running when you're washing the bottle. And our product uses about 1 liter of water.
Thank you very much, Green Team.
What's a class without students, right? So here's our tribute to them.
Out my hand, I may say you, I may tell you to run. I'm gonna say Maria, pick me up with golden hands. I may say you, I may tell you to run. I'm gonna say Maria. I would like to hold my little hand. We will run, we will crawl. I would like to hold my little hand. We will run, we will crawl. On the way, on the way, on the way. On the way, on the way. On the way, send me on my way, on my way, on my way, send me on my way, on my way, on my way, on my way. I would like to hold my little hand. We will run, we will crawl. I would like to hold my little hand. We will run, we will crawl. Send me on my way. Send me on my way. Send me on my way.
Let's have a big round of applause for the class of 2010.
They're red, they're white, they're brown. They get that way underground. There can't be much to do, so now they have blue ones too. I imagine them up in their acres, out at Idaho, up in Maine. I wonder if they will be bakers. Their niches, their luck is a plane. Oh, potato, potato, potato. Potato, potato, potato. Potato, potato, potato. Potato, potato, potato.
Is Yellow Team.
Hi, we're Yellow Team, and this is Chef Pierre. Some time ago, Chef Pierre went to France to study at a culinary school. On his first day, he was slicing tomatoes, and on his second, his instructor handed him a potato and told him to tourné it. Naturally, Pierre was very concerned about performing such a famous cut because all of his chef friends told him that it would be the first cut he would learn and the last one that he would master. In order to accomplish it, he had to cut a potato into smaller pieces and then take one of those pieces and slowly whittle it down until he had achieved a perfect tourné, which is marked by its 7 sides, rounded taper, and length, which is between 2 and 3 inches. Pierre practiced day in and day out, but it was not until he had aced sauces and soufflés that he could finally say he had mastered the tourné. Upon graduation, he went to the United States and opened a collection of French restaurants. They were very successful, but much to his chagrin, his prep chef could not cut tournées like he could, and he couldn't afford the resources to train him. He needed a mechanism that would allow his prep chef to do it, but without sending him to the fancy culinary school he'd gone to. But finding such a mechanism was no easy feat. It couldn't just slice, but it had to taper. And it couldn't cut well once, but 7 consecutive times. There were no existing products that could cut anything like it.
Until the True Tournée, which is our elegant solution to Chef Pierre's culinary conundrum. The True Tournée enables a user to take a rough-cut potato and transform it into a beautiful tournée without any formal training. In our kitchen, Dan is going to show you how he cut it with ease. And I should tell you, though Dan makes a mean macaroni and cheese, he's no culinary expert. So first he took a rough cut, similar to what he would use if he knew how to do it by hand. He doesn't. Then he loaded it into our device, and as you can see, he's making several cuts. 7 cuts later, he'll soon be done. Now I want to break it down for you a little closer in a video. First, the chef has to make pre-cuts from a whole potato and turn it into rectangular prisms. This is a pretty easy task for most chefs, and they could probably do it in their sleep. But we've included markings on our cutting board just to make sure we got the sizes right. After the pre-cut is done, it's time to cut the potato. It is, with one hand, the user holds the potato, while with the other, he or she squeezes the scissor-like handles to pull the end mounts in. Then, cutting is as simple as moving the handle through the potato and back again. After the cut's been made, the user uses his or her thumb to ratchet the device the 1/3 turn. This ratchets the potato the 1/7 turn. 1/7 turn. After this has been done 7 times, the potato is then ready to be pulled out. Using those scissor-like handles again, the potato is easily released. The only thing this video can't show you that I wish it could is how little force is required to actually cut the potato.
Let's take a look at how exactly our design allows this complicated cut to look so simple. First, we look at loading. The 2 end mounts move together using a rack and pinion mechanism. These end mounts are connected to the Delrin handles on the side. That way, the user can very easily open and close it. Here you can see it's open, and the pre-cut can very easily be inserted into the device, and the device is now closed. Now, the pre-cut has been mounted such that it's ready to be cut. However, the end mounts determine the length of the tournée. However, we also need to be able to adjust for the cutting radius. This is done using this blade, which is sharpened carbide. The blade can make 100,000 cuts before dulling. Therefore, it's very, very unlikely that it would ever need to be replaced. In order to change for different cutting radii, the user uses the knobs as shown as highlighted here. First, the top knob is loosened, the handle is pulled out to the user's desired length, retightened, and now the user is ready to make his first cut. The blade travels along an arced path as determined by the pivot point on the handle. This is the most efficient design because it eliminates unnecessary friction and also fully constrains the blade path to make the perfect tournée cut. In order to turn our potato, we designed a ratcheting system that allows the user to turn the potato exactly 1/7 each time. The ratcheting works by turning the ratchet, which slides the pin. This pin compresses the spring. Eventually, when the spring reaches the end of the tooth, the spring releases, snapping the pin into its ratchet, giving the user the feedback that he needs so that he knows that he's turned exactly 1/7. This ratchet and the knob, and every other part that the user touches is black. The rest of the device is made out of stainless steel for food safety and industrial look. Once you're done tourneing, cleanup is as easy as tossing in a dishwasher.
Chef Pierre loved our design and wanted to purchase a true tournay for the prep chefs in his kitchen. In high-end French restaurants like Pierre's, money could be saved by having the prep chefs instead of the highly trained sous chefs preparing their tournays. Chef Pierre is not alone. These are all of the French restaurants in Boston and Cambridge. From the ones we surveyed, about half of them didn't serve tournays currently because of the time and skill required to make them. These are all of the French restaurants in the 20 largest cities in the United States. Together, they sum to over 20,000 French and French fusion restaurants. This number doesn't even include other places that might serve French food, like France. Many of these restaurants are French bistros, such as Petit Robert Bistro. We consulted with Chef Robert throughout the semester as we refined our design. We projected that our product would initially cost $150 to produce. By benchmarking it against other industrial cutting devices, such as a mandolin or a julienne slicer, we would price it at $200. We expect, although you cannot put a price on the perfect tournay. We expect to sell about 1,000 true tournays in the first year. With sales rising annually, we plan to capture about 10% of the market. When we consulted with America's Test Kitchen, they predicted that a product with the True Tournay's capabilities would be sold to every French restaurant. So we think 10% is a pretty conservative estimate. This business plan sets us up to break even in 2 years. These numbers do not include our product's high potential to enter the home user market, which would not only accelerate our break-even point, but also satisfy every food enthusiast's need for authentic French cuisine. Our team set out to solve Chef Pierre's tournay predicament. We needed to design a product that could cut the perfect tournay every time, a product that was effortless and intuitive, a product that could be used by anyone. With inspiration, technical expertise, and guidance, we produced a simple and elegant solution, the True Tournay. Bon appetit.
Thank you, Team Yellow. Any questions for Team Yellow? We have a question back here.
Thanks. This is actually a comment. It's directed to all 8 teams. I just wanted to congratulate you guys all. It was absolutely outstanding. I think it's really interesting you start all the way from developing something for the developing world all the way to the highest end French restaurant. And really it's evident to everyone here in the audience how much you've learned, how much fun you've had. We're all very proud of you. I hope you guys are equally proud of yourselves. And also congratulations to Professor Wallace and the whole instruction team because you guys did a brilliant job.
We have a question here.
Yes. It looks like a very wonderful product. I was wondering, since you mentioned that the video doesn't quite show how easy it is, what would you compare it to? Like cutting a sheet of paper? That simplicity?
Using our device has about the same force requirement as actually cutting a potato with the sharpest kitchen knife that they use. It's about 3 to 5 pounds of force. Since our device is actually lower, you can kind of leverage your body against it. It's pretty easy.
Come by our booth later and try it.
We have a question over here.
How many of the French restaurants that you've interviewed currently serve plates of tournays, and how much does a plate of tournays cost?
So I said it was about half of the small sample size that we talked to. But a number that America's Test Kitchen gave us was that each tournay actually added about $5 to a plate. So it's a pretty significant amount.
We have another question here.
Did you consider at all combining the knife return and the ratchet into one mechanism so it automatically advances the tournay?
We did consider that design, and with the tournay actually being the elegant cut that it is, it's actually nice to have the user actually doing all the mechanisms. So it's like you still have a feel for the product. It's not like you're completely automating the process.
We actually have time for one last question. I think here, Allison.
It's already been said, but I just wanted to reiterate how amazing the night has been and how impressive you all are. I was wondering, what is it that makes 2009 so special?
So this is a tricky question. I'm inclined to say that it's because the MIT class of 2011 is so phenomenal. But in all sincerity, if there is one thing that every 2009 student and product have in common, it is Professor David Wallace. He has led this class with enthusiasm, devotion, and brilliance for the last 15 years. 2009 was a record size this year, and his dedication merely intensified, much to the delight and awe of his students. We put in countless hours into this class, but our time commitment pales in comparison to what Professor Wallace puts into 2009. He is deeply humble and refuses to take credit, so the students decided to find a way to say thank you. So with that, I'd like to invite Professor Wallace on stage with a representative from each team so that we can give him a small token of our profound gratitude. Each student was asked to submit a word to describe either Professor Wallace or the course, and they were all compiled into the shape of a 2009. We all signed it in our team colors on the front and wrote you a note on the back. And I have to say, while they get it set up, that it's a shame that you all can't read these, because amidst all of this color-coded madness, you can read that you have inspired us to become designers, reinvigorated our love for engineering, and actually repeatedly mentioned you've exponentially increased our regard for Canadians.
Yes.
Right there.
And perhaps most impressively, almost half of the class said that this is the best class they have ever taken at MIT. Thank you, Professor Wallace. It has been truly extraordinary. Thank you.
Thank you. And I think the only thing I can say is let's have a big round of applause for the students. It's been a great year, and that's it for tonight, but we can now go out to the foyer, meet the students, try out the products, and have some great food to eat. So let's see you outside. Thank you.